Now, let us introduce the Part 2, Optical Imaging Method. Optical imaging methods include diffuse optical imaging, ballistic optical imaging, bioluminescence imaging, and fluorescence imaging. How photons interact with biological tissue. Chemical imaging or molecular imaging involves interference from the deflection of light emitted from cells to structure, texture, anatomic, and chemical properties of material. Optical imaging systems may be divided into diffusive and ballistic imaging systems. Let us first see diffusive optical imaging. We also call it DOI, include diffusive optical tomography and near-infrared optical tomography. Diffusive optical tomography, DOT, is emerging as a viable new biomedical imaging modality using visible and near-infrared light. This technique can probe the absorption and scattering properties of biological tissues. The main applications are currently in brain, breast, limb, and joint imaging. Because of its safety, no radiation damage, DOT is attracting increasing attention. This method has many advantages, which include the price of the technology of the imaging equipment cheap, faster data collection, applies to the patient for long-time monitoring with other imaging technology, all the advantages. The principle of diffuse optical tomography imaging to launch a group of near-infrared light into the biological tissue, photons diffused within biological organization, and then placing a certain number of detectors on the surface of the biological tissue. Optical flow can be detected by these detectors when photons diffused into the edges of the tissue. Application of transmission equation with optical flow, optical parameters can be reconstructed within biological tissue. The advantages of diffusive optical tomography. The spatial resolution of DOT, about several millimeters. The temporal resolution of EROS, milliseconds. DOT instruments are relatively low cost. The signal-to-noise ratio of NIRS is quite good, enabling detection of response to signal events in many cases. Important chemicals that this method can detect include hemoglobin and cytochromins. 2. Near-infrared optical tomography, NIROT, a technique that gives the ability to simultaneously obtain information about the source of neural activity as well as its time course. In other words, it allows them to see neural activity and study the functioning of the brain. A near-infrared laser is poisoned on the scalp. Detectors composed of optical fiber bonds are located a few centimeters away from the light source. These detectors sense how the path of light is altered, either through absorption or scattering, as it travels brain tissues. This method can provide two types of information. One, to measure the absorption of light, which is related to concentration of chemicals in the brain. Two, to measure the scattering of light. This is related to physiological characteristics such as the swelling of glia and neurons. Typical applications include rapid 2D optical typographic imaging or near-infrared spectroscopy signal following brain activity and tomographic reconstruction of an entire 3D volume of tissue to diagnose breast cancer or neonatal brain hemorrhage. Ballistic optical imaging. Ballistic optical imaging systems ignore the diffused photons and rely only on the ballistic photons to create a high-resolution image through scattering media. Ballistic photons are the light photons that travel through a scattering medium in a straight line. If laser pulses are sent through a tubed medium, such as fog or body tissue, most of the photons are either randomly scattered or absorbed. However, across short distance, a few photons pass through the scattering medium in straight lines. These coherent photons are referred to as ballistic photons. Okay, that is all for this part. Thank you.